notes for lesson 5.1, graphing quadratic functions in standard form. Now these notes are ones that we did in class, but again this video is just for you to reference if you need to go back and hear an explanation again. So again, these notes we took in class, and this is the first part of 5.1, the graphing section of quadratic functions. So the first part of chapter 5 we looked at solving quadratic functions. So this part we are going to look at the graphs and what those look like and how we graph quadratic functions. So as a review, a quadratic function in standard form is f of x or y equals ax squared plus bx plus c, where a does not equal 0. And a quadratic function will graph as a parabola. If you remember from the beginning of chapter 5, we did an activity where we had a string hanging on the board. We talked about the form of a parabola and what it looked like and the different parts. We're going to look at those parts again and identify them and talk about what they mean in the quadratic function. So example 1, we're going to change each of these to standard form. In order to graph in standard form, our function has to be in standard form. Now we're going to talk about this later on, but part A is in intercept or root form, because you'll notice it is written as factor. So if we factor, we notice that we put it in two binomials, so we call that intercept or root form. So to get to standard form from intercept or root form, we're just going to use FOIL and multiply it out. So the first thing we want to do is FOIL. So we're going to do x times x. Again, our negative is on the outside. So we have x squared. X times negative 2 is negative 2x. 3 times x is 3x. And 3 times negative 2 is negative 6. Next, we need to simplify like terms. We still have our negative out front, and we can combine our x's. So we have a negative 2x and a 3x, which is plus 1x minus 6. And then we just need to distribute the negative into our parentheses. So we have negative x squared minus x plus 6. This function is now in standard form because it's an ax squared plus bx plus c is the form it's in. Now, in order to determine whether our parabola is going to open up or down, we look at the coefficient in front of our x squared term. If we notice here it is negative, so this tells us that our parabola is going to open down. If it's positive, it's going to open up. For example B, this is in vertex form. Again, we're going to talk about these forms in the next section as well. Vertex form, you'll notice that you have something quantity squared, and that tells us that it is in vertex form. So vertex form, again, we need to multiply this out. When we have quantity squared, remember this is the same as saying x plus 2 times x plus 2. So we have 1/4 times x plus 2 times x plus 2, and this is equal to y minus 3. So then just like we did for part A, we need to FOIL out our binomials. So we have y minus 3 equals 1/4 times, if we multiply this out, we get x squared. We get 2x and 2x, which is 4x. And 2 times 2 is 4, so plus 4. Still y minus 3. I'm going to distribute in my 1/4. So I have 1/4 x squared plus 4 times 1/4 is just x plus 1. And then I'm going to add 3 to both sides. So I get 1/4 x squared plus x plus 4. And again, we look at the coefficient in front of our x squared term. Since it is positive, this parabola is going to open up. So again, in order to graph in standard form, sometimes we need to rearrange our equation so that it is in ax squared plus bx plus c form. Again, the coefficient, or the a in front of our x squared term, tells us whether our parabola is going to open up or open down. When we did our activity at the beginning of chapter 5, we talked about the different parts of a parabola. The first part of a parabola is the vertex, and that is the lowest or highest point of the parabola. We also call this the maximum or minimum. Depending on which way our parabola opens up or down, that will determine whether it is a maximum or a minimum. So if we look at the picture here, our vertex is, again, the lowest point, so in this case it's a minimum. So the vertex is 2, negative 4 in this case. And in our equation, we call this hk. And again, this is the vertex. Second part of a parabola is the axis of symmetry, and this is the vertical line that passes through the vertex of the parabola producing a mirror image of each half of the parabola. So we know that there's an invisible line through the center of the parabola that shows us that we have a mirror image. So in blue is our axis of symmetry. Now the axis of symmetry, the equation to find the axis of symmetry is x equals negative b over 2a. And you'll notice that we can use this to find the vertex as well. So to find the vertex, we're going to take the opposite of b all over 2a. That's going to give us our x coordinate. We're going to plug that in to get our y coordinate, and that will get us our vertex. So we know that the axis of symmetry is just the x-axis of our vertex. And again, a parabola opens up if a is greater than 0 or a is positive, and it opens down if a is negative or less than 0. There are two other important parts to the parabola, and the next one is the points on the x-axis. We know that these are called the x-intercepts. We can also call these roots or solutions. And we know that in the beginning of chapter 5 when we were solving for these points on the parabola. So in this case our x-intercepts or our roots are 0, 0 for the vertex and 4, 0. And the last point on the graph that's going to be important is your y-intercept. Again, this is where the graph crosses the y-axis. In this case, our y-intercept and our root is the same. So our y-intercept here is 0, 0. It's not always going to be the case, but in this case, the root and the y-intercept are the same point. So again, these are the important parts that we need on our graph in order to graph a parabola. So using the equation or the formula for finding the vertex, you're going to find the vertex of the equation from example 1, part B. So our equation for part B was y equals 1/4 x squared plus x plus 4. So the formula for the vertex is x equals the opposite of b all over 2a. And again, this is going to give us the x coordinate of our vertex. So the opposite of b, we know that b is 1, so it's negative 1, all over 2 times a, which is 1/4. We multiply that out, we get negative 1 over 1/2. Multiplying by a fraction is the same as multiplying by the reciprocal. So this is negative 1 times 2, which is negative 2. So the x coordinate in our vertex is negative 2. Now to get the y coordinate, we're just going to plug this value back into our original equation. So we have y equals 1/4 times negative 2 squared plus negative 2 plus 4. And you just plug that in your calculator with all the parentheses, and you should get y equals 3. So our vertex is negative 2, 3. So again, once you've found your x coordinate with this formula, we just plug back into our equation to get our y coordinate. Next, we're going to look at the steps for graphing the quadratic function from standard form. So if our equation again is in standard form, y equals ax squared plus bx plus c, then there's a certain steps that we need to find or to use in order to find the vertex and the x coordinates that we need to graph the function. So our first example here, we have y equals negative x squared plus 4x minus 2. The first thing we want to find is the x coordinate of the vertex. And we did that on the previous page. Again, our formula is x equals the opposite of b all over 2a. So our b value here is 4. So this is negative 4 all over 2 times. Now our a here is negative 1. So 2 times negative 1. So we get negative 4 over negative 2, which is positive 2. So the x coordinate of our vertex is positive 2. Just like we did on the previous page, we are going to use our x coordinate to find our y coordinate. So we're going to take our x value, we're going to plug that back in to solve for y. So y equals negative 2 squared plus 4 times 2 minus 2. Again, if you plug that in your calculator just like you see it, you should get y equals positive 2. So our vertex is 2, 2. So if we go over to our graph, over to up to, this is our vertex, and again it's the point 2, 2. Now looking at our original function, we know that our a is a negative, so we know that our parabola is going to be opening down. We need 2 other points on our graph so that we can see where our function is going to fall once we have the vertex. So in order to do that, the next thing we're going to do is to find the y-intercept. Now you could find any point on your graph, but the y-intercept is going to be the easiest one because we know at the y-intercept that x equals 0. So it's going to make it very easy to find a point if we use the y-intercept. So to find the y-intercept, we know that x equals 0. So we're going to plug in x equals 0 into our equation. So we have y equals negative 0 squared plus 4 times 0 minus 2. So we know that y is equal to negative 2. And again, this is the point 0, negative 2. And I'm going to do the y-intercept in blue. So we're going to go 0, negative 2. So we're going to go down 2, and that is our y-intercept. Now, like I said, we need one other point. We need a total of 3 points on our graph to see where our function is located on the graph. So in order to find one other point on our graph, we need to find the axis of symmetry. If you remember, your axis of symmetry goes through your vertex. So the equation for the axis of symmetry is just our x value of our vertex. So our axis of symmetry is x equals 2. I'm going to label that on the graph. So now that we know the axis of symmetry, we know that our second point is going to be the same distance from the vertex on the other side, or on the right hand side of our graph. So if you notice, our y-intercept is 2 units away from our vertex. So our next point is going to be 2 units away from our vertex the other way. So our other point is going to be at 4, negative 2. Now that we have our 3 points, we can connect them. Again, we know it's a parabola, so make sure that your graph is curved. So that is our function, or our graph of our function. The next example, we're graphing the equation y equals x squared minus 6x plus 11. Again, the first thing you should notice is our a is positive, so this one is going to be opening up. So first we want to find our vertex. Again, the equation is x equals the opposite of b all over 2a. So we're going to plug in those values. The opposite of b is negative 6. So the opposite of b would be positive 6 over 2 times 1. So 6 over 2 is equal to 3. So the x value for our vertex is 3. Again, to find the y value, we're just plugging back into our formula. So y equals 3 squared minus 6 times 3 plus 11. Plug that into your calculator, and y equals 2. So our vertex is 3, 2. Next, we're going to find our y-intercept. Again, if we're finding the y-intercept, then x equals 0. So we're going to plug in x equals 0 into our equation. So y equals 0 squared minus 6 times 0 plus 11. So y equals 11. So our y-intercept is 0, 11. So my point is way up here, a little bit off the graph. And last, we need to find the axis of symmetry. Again, that's simply the x value of our vertex. So the axis of symmetry is x equals 3. So again, we can draw that dotted line through the vertex. So then we can use that to find our next point. So notice that our y-intercept and our axis of symmetry are 3 units apart. So on the right-hand side of our axis of symmetry is where we will find our other point for our graph. And then again, connect them. So this is the graph of our parabola. So again, in standard form, we need to find the vertex, find the y-intercept, and then find the axis of symmetry to find that third point. In order to graph a parabola, we need at least 3 points. So those 3 points will help us to graph our parabolas. The next section, we're going to look at graphing in different forms. So again, this is just standard form.